In this chapter, we're going to actually start working with the data. So we're going to start off by talking about how to collect your information into categories so that you can look for patterns and trends. When you're looking for patterns and trends, there are some particular things in statistics that we tend to look for. Many of these we will come back to later in more detail, but for now we will talk about kind of generally what these look like when you group your data. The first four will be what we focus on: center, variation, distribution, and outliers. It is important in statistics how things change over time, but that tends to not affect our calculations as much. So for now we'll be looking at graphs of data and trying to figure out this information based on that. So it'll only be estimates right now, and then in chapter 3 we'll come back and actually look at how to calculate these things. So before you can actually look for these patterns and trends, you need to organize your information in some sort of way. That's going to be the focus of this chapter. In this section we're going to start off talking about how to organize the information into frequency distributions. Frequency distributions break your data into categories and then tell you how many of the subjects in your study fall into each category. It just sort of helps you organize the information. You can use a frequency distribution to organize both qualitative and quantitative data. For qualitative data, you just list your categories and then list the frequency for each category, so the number of subjects that fell into each category. Here I have an example with 10 people and their eye colors. With a quantitative frequency distribution, we need to break the possible values up into different ranges, and each of those ranges is called a class. So here I have an example where we've done a survey of a church group, 45 people, for their ages, and then we've broken the ages up into categories or ranges, and so those are the different classes. Now we're going to use this church group example to talk about some vocabulary that goes along with frequency distributions. So I mentioned that each of the age ranges is called a class, and then the lower class limit is the lowest number in each of those classes. So in this case the 0, 10, 20, and so on. So the lowest age that would fall into that group. And then the upper class limit is the highest age that falls in each group. So in this case 9, 19, 29, and so on. The class width is very important. This is how wide each class is. What you really want to be careful of, though, is that this measures from the beginning of one class to the beginning of the next. So since the first one starts at 0 and the second one starts at 10, that means the class width is actually 10. You do not look sideways and say that since it goes from 0 to 9, it's 9. Okay, so the class width goes from the beginning of one class to the beginning of the next. The class boundaries don't actually appear in the frequency distribution, but they're the numbers that would separate each of the classes, so halfway between. So one class ends at 9 and the next begins at 10. That means the boundary between those two would be 9.5. So the boundaries are 9.5, 19.5, and so on. Although you do also have a boundary below the lowest one, so we have one at negative 0.5, and then also above the highest one, so the highest boundary would be at 99.5. And then the class midpoints are the halfway points in the classes. So from 0 to 9, the midpoint would be 4.5. From 10 to 19, the midpoint would be 14.5. You're actually averaging the two numbers, so 10 plus 19 divided by 2 would give you the 14.5. So midpoints are the halfway points in the middle of each class. So how do you actually create the frequency distribution table once you have a set of data? We actually have a pretty specific process that we go through to calculate these. The first thing is to figure out how many classes, how many groups you want. I will usually give this to you but it should be a number somewhere between 5 and 20. And then once you have that figured out, you need to figure out how wide each class should be. So we actually have a formula for that. You take your highest data value and subtract the lowest data value, and then divide by how many classes you want. Once you figured that out, you need to decide where you want your starting point to be. And actually, sometimes you'll figure out your starting point first, because you might use the starting point instead of the lowest data value to calculate your class width. I'll mention that again on the next slide. Once you know where you want to start, then you can fill in all the lower class limits using your class width, and then you can go in and fill in the upper class limits, and then you just count how many data items fall into each group and fill in the number. So let's go ahead and look at an example of that. Okay, so here's a list of data. Just in order to talk about it, let's say these are ages. So we've got a list of ages here, and we're asked to construct a frequency distribution with 4 classes. So we want 4 age ranges to put people into. So based on that, the first thing I need to figure out is, with 4 classes, how wide would each class be? Let's say that I'm going to go ahead and start my lowest class at 3 because that's the smallest number in the list. Now if I wanted to round that down to a nicer number and just start at 0, I could. And I'll mention how that would change things. But let's say we're starting at 3. So if I'm going to start at 3, then to find my class width, I need to take the highest number in the list, which is 45, and subtract the lowest, which is 3, and then I'm going to divide by how many classes I want. And that comes out to 10.5. We're going to go ahead and round that up to 11. You'll always just round up to the next whole number. So that means that our class width needs to be 11. All right. Now that would be different if I had decided to round my lowest number down to 0. Then I would have done 45 minus 0 over 4, and that would have given me a different class width. Okay. All right, so with a class width of 11, then I would go ahead and start filling in the lower class limits, the starting numbers for each range. So I'd write down the 3, and then I'd say, okay, if I'm going to add 11 to that, that means the next one will start at 14. And then I'll add 11 to that, and that means the next one starts at 25, and then 36. Once I have those filled in, then I can go and fill in the highest number in each range. I can say, okay, since the second one starts at 14, that tells me the first one must have ended at 13. And since the third one starts at 25, that means the second one must have ended at 24. And then I can look and see that those upper numbers go up by 11 each time also. So I can fill in 24 plus 11 is 35, and then 35 plus 11 is 46 for the high end of my highest class. Okay, and then once I have all of those ranges figured out, I just need to go back to that list of data and count how many of the numbers fall into each range or into each class. And so I did that, and that's where I came up with the 7, 4, 3, and 1. And then if I wanted to, or if I ask you to, you can change a frequency distribution to a relative frequency distribution. And that just means that you change all the frequencies to either decimals or percents. So in this example, this is going back to the church group example, not the one that we just created. Looking back at that example, there were 45 different ages. And you can figure that out again by adding up the frequencies if you want to. That means that I need to divide each of those frequencies by 45 to figure out what percentage that actually is of the total size of the group. So on that first one, the frequency was 5, and so I divided by 45. That gave me 0.11. You can either leave it as 0.11 or you can go ahead and write it as 11%. And so I did that for each of those frequencies. And do rewrite the whole table. This is a new distribution, so you rewrite all of your classes and then give it a new heading that says relative frequency instead of just frequency, and write down all your percentages. So that gives you a relative frequency distribution. Just means that all of these are percentages instead of actual counts of how many people, but overall it still gives you essentially the same information.